Number 18. Diagram shows the first 10 sides of a spiral pattern. It also gives the length in centimetres of the first 5 sides. The lengths in centimetres of the sides of the spiral form a sequence. Find the expression in terms of n for the length in centimetres of the nth side. So we've got a sequence. We've got a sequence that goes 1.5, then 3, then 5.5, then 9, and 13.5. So that's our sequence. So let's have a look, see what it's going up in. I've lost my 1. Where's that going? So 1.5 to 3, 1.5, 2.5, 3.5, 4.5. So that's the first difference. Always label what you're doing. Badly in that case. Then we'll do the second difference, which is, oh, that's easy, that's 1, 1, 1. So actually, because the second difference is the same, it's something to do with n squared, and we half this number for our coefficient. So we've got a half n squared. So in other words, we've got half the square numbers. Well, 1 squared, if we've got these are our positions, so we've got 1, 2, 3, 4, 5. So 1 squared is 1, half it is indeed a half. 2 squared, 4, half it, 2. 3 squared is 9, half it, 4.5. 4 squared, 16, half it is 8. 5, 25, half it, 12.5. Now, we know the first bit of our rule is half n squared. But if we look at the difference each time, we've got between 0.5, 1.5, 2 to 3, 4.5 to 5.5, 8 to 9, 12.5 to 13.5. I could take them away, generate another sequence, but basically it would just show us that we need to do half n squared, so this value here, add 1 to it, and we get the 1.5. 2 add 1 is 3, etc. So actually our rule is half n squared plus 1.